So this is the first session of JavaScript for React.js. In this episode, we are going to talk about the timeline of JavaScript, which is basically the history of JavaScript. The reason we are talking about the history of JavaScript, or any programming language for that matter, is that it's very important to know the history of JavaScript, because you realize that there are some things about JavaScript that you may not like, and when you do not have the context, you just hate JavaScript. So the history of JavaScript give you that context. The whole ecosystem of JavaScript becomes very overwhelming because there's so many libraries, so many places, so many things, and so many things JavaScript can do, and even like multiple syntaxes to do the same thing, and it might become very overwhelming for somebody who is a beginner. So even from that perspective, JavaScript history helps, and you will not find any programming language other than JavaScript whose history is as interesting as JavaScript's. So to start JavaScript history, I'll start with the history of the personal computer revolution itself, because JavaScript is nothing but a lot of computers connected, and then the internet is there, and then the web is there, and then there is a default language that runs on the web, which is JavaScript. So it makes sense to talk about personal computer revolution. So as you might know that in the late 70s and early 80s, Microsoft and Apple was leading the revolution. Most of the things that was very revolutionary, Apple started those, although Apple copied the idea of like things like GUI, mouse, and kind of not copied the idea which it could have is OOPS and networking from Xerox Research Lab, and Microsoft just copied Apple and or indirectly Xerox itself, and that started basically the good looking computer revolution that we have, which is basically making it super convenient for everybody to plug into computers and use them. And if you know the history of Apple itself, you might know that Steve Jobs was very difficult to work with, and there was a power struggle, and he was told to step down as CEO, and he hired a guy who was actually CEO of Pepsi, John Scully, I think, and he went to Scully and asked him to become the CEO of Apple instead of Pepsi. And Pepsi was obviously a big deal, and Apple was kind of a startup back then, but everybody knew that what Apple was doing is really amazing, and he ended up convincing Scully because he was kind of a fan of Scully because of his marketing strategies and all. So Jobs said this famous line to Scully that, do you want to change the world, or do you want to sell sugar water your whole life? And that one-liner really had its impact on Scully, and he ended up quitting Pepsi and working for Apple as a CEO. And eventually what happened is, because of this power struggle that was going on and nobody liked to work with Steve Jobs, especially the board of directors and all, they ended up excluding him as a board of director, and Steve Jobs decided to leave Apple, although he had a lot of shares in Apple. Over the time, Steve Jobs founded two different companies. One was Next and another was Pixar. And Pixar was later on sold to Disney, and Next was later on acquired by Apple. And Next was more into creating high-end computers, which provided a lot of GUI, and mostly the focus for Next was high-end computing for research organizations, large corporates, education-wise large organizations like top universities like UC Berkeley or Harvard or things like that. One of the places Next was being used was CERN, CERN, right? And it was one Next computer, which was because Next computers were quite powerful and very expensive. They also provided a lot of GUI tools for you to create your own GUI tools or GUI applications. And it was this next computer where Tim Berners-Lee used it to create the first web server and web browser, and this is where the web was invented, right? So if you think about it, when Tim Berners-Lee created the World Wide Web, it was literally one single server accessed by the sun itself. And interestingly, if that server crashed, you would say the web is down, right? And the browser was called World Wide Web, but over the time World Wide Web became a synonym of kind of internet. And to reduce that confusion, World Wide Web browser was renamed to Nexus. So Tim Berners-Lee is called the father of World Wide Web because of this thing, and he created this so that information can be shared easily inside CERN. And I can show you how the web browser, for example, this World Wide Web. So earlier what happens is we used to have a lot of terminal tools, right? GUI is not that common. Although Next supported GUI and Apple supported GUI and all those things, earlier what used to happen is like people used to have a low-end monitors, TV kind of monitors used called terminals, and you will connect one to one server multiple terminals, and you will basically share computation time on the same server, and all you will have is a single terminal with a keyboard, right? So not all the terminals will have their own dedicated CPU. And a lot of data sharing or information sharing or information viewing for that matter was done on terminals like these, right? GUI was not that big of a deal in the 80s especially, and eventually in the 90s that will change, and this will lead to a lot of things that I'll show you. So this is the World Wide Web version that used to run on a terminal. And earlier web and websites were more about just links to pages, and then those pages will have hyperlinks, and you click on those hyperlinks and you go to places. So think of earlier version of web as how you have Wikipedia, and you click on one link to another link and you can just go from one information to another, but no images, no videos, no logos, no nothing, only text. So that's kind of the earlier version of web. And this is how the browser used to look like. This is not exactly what how it was, because the first version of World Wide Web that he created had no colors, but he didn't know that it will get so famous, so there are no real pictures of the first version. So all the images that you will get on the internet is kind of the recreation of what he created, and or version 2 or version 3 of it. But the first version was just grayscale. There was no colors. So what happened is eventually in the mid 90s, internet became a thing. Everybody was trying to connect on the internet. That was like the thing that everybody wanted to know, like what is internet, and it was a big deal, and people were not so comfortable, but everybody knew that it is the future, and some people realized it. So there was a team in University of Illinois. They decided to create a GUI web browser, and they decided to keep it cheap. People can license it, and some other organizations or individual can use it for free and things like that. And Mark Anderson was a student back then in University of Illinois, and they were working on this project called Mosaic. Okay, and Mosaic became kind of one of the first web browsers that had GUI and can be used commercially and things like that. So Mark Anderson decided to start his own company after University of Illinois, after graduation from there. And what he did is he started a company, and he decided to name it Mosaic also, because Mosaic was his baby also from the open source lab where he was working in University of Illinois. But due to legal reasons, he cannot name it Mosaic. So in his small team of people, they kind of brainstormed together and decided to come up with a name called Netscape Navigator. Okay, And what happened eventually is that Netscape became a very big deal. It was not free back then. Free browser was not a thing. And what happened is it used to be $100 a year or something like that. And Netscape became a multi-million-dollar company in few months, literally. Okay. And it was way ahead of its time, because it has UI, it has JPEG image support, and they realized that you need a programming language just for websites. But the vision was that maybe websites are simple. Like, for example, back then websites were super simple. They were just text, information, and logos and things like that, and you go from one place to another. And nobody imagined web what it is today, because the web today is way ahead of any computing power anybody had back then. So they only thought of web as an information thing, and they thought multimedia makes sense for information, because images and text and videos make sense to have as a thing for information, right? So Mosaic wanted to do that, and he wanted to Netscape wanted to do that. And Mark Andreessen decided to go for a programming language that can run on their Netscape browser, and they hired a guy, Brendan Ike, and they asked Brendan to create a programming language which is kind of a glue language for the Netscape Navigator. And Brendan hacked together a programming language which was quite generic, not specific to the browser itself, but generic in the sense of you can use that language in anything. But obviously it only ran in Netscape Navigator, since the interpreter was written inside Netscape Navigator itself. And they called it Mocha, and then later on LiveScript, and later on JavaScript. JavaScript has nothing much to do with Java. What happened is they knew that Java was a famous language, and if they called their language JavaScript, people or programmers would try to get interested in a programming language. Obviously, they cannot name their language just JavaScript without talking to Sun Microsystem, because Sun Microsystem owned the trademark to Java. So they had this thing with Sun Microsystem that, okay, this is our programming language, but you can have the trademark for JavaScript. And later on, since Sun Microsystem was bought by Oracle, so now Oracle's on the trademark of JavaScript, which is an interesting fact. Won't be useful to you in your life ever, but it's interesting that JavaScript is not owned by any company that you might imagine, but it's actually owned by Oracle because of this reason. So they moved from Mocha to LiveScript to JavaScript, finally settling with JavaScript. And later on, what happened is, since Netscape was making so much money, and obviously it was a software company, right? And everybody knew that web or internet was the future. So enters this villain, which is Microsoft. And what Microsoft does is, Microsoft creates their own web browser, which is called Internet Explorer, and they create a language, JScript, which is basically nothing but copy of JavaScript. Obviously they cannot use the name JavaScript, so they came up with a name JScript. And JScript had minor differences with JavaScript. And if you want to use Netscape Navigator, you have to buy it for a cost of $100 a year or something like that, right? But what Microsoft did to take over the market of web browsers, they gave Internet Explorer for free whomsoever buys Windows, right? So if you're buying Windows, you get Internet Explorer for free, and you can virtually do everything that you can do in Netscape Navigator. And since a lot of people were using Windows, and it was majority share when it comes to operating system, what it eventually did, it started eating all the share of other browsers, especially Netscape Navigator, which was a majority web browser back then. And this is not the only thing that Microsoft did. It did the same thing with other things. For example, there was a company, Lotus, which used to do this program, Lotus 123, which is basically a spreadsheet thing that used to work on terminals. Since nearly everything used to work on terminals back then. So as you can see on the right, there is this screenshot, and this is how Lotus 123 used to look like. It is basically a table, just like an Excel sheet, and it's basically a terminal program. So Microsoft Office obviously created their own version, and I think even their first few versions were GUI, and they gave it for free, even that, and it did same with Netscape Navigator, and there were 2-3 more things like that. And there were a lot of cases against Microsoft to do this unethical thing, to kill their competition, just because they have all the money in the world and they have all the share of operating system when it comes to computers, right? And there was a case against United States, against Microsoft, which was United States versus Microsoft Corporation, and it is also known as Microsoft Antitrust case. And eventually Microsoft was fined, but later on nothing much happened basically. Okay, they were fined, and they were using this version of there was a company that was behind Mosiac, and Internet Explorer was kind of using their code, and there was a pact between the company Spyglass, which was providing this license kind of thing for Internet Explorer to use the web browser code. And what Microsoft did is they told, we will give you certain percentage of the profits that we make from Internet Explorer. But since they gave Internet Explorer for free, they were not giving anything to Spyglass. So literally they had the whole code for free, right? So the only punishment they got was they ended up giving some $8 million or something to Spyglass software. And they had this pact with Spyglass that after this 8 million we owe you nothing, and we'll keep on using your code, or we are basically done with this license, right? And with respect to Netscape Navigator or Lotus 123 or things like that, nothing much happened. Microsoft later on took out Microsoft Office as an individual entity, and you have to buy it separately, but they went with Internet Explorer as a free thing over the time. And since JavaScript and JavaScript was so different, right? And there were like two browsers in the market, and they were like 40-60 or 30-17 market share. In the beginning, it took few months to a year or two for Netscape Navigator to come little bit down, and eventually what will happen is over the years Netscape Navigator will become nothing, and Internet Explorer will literally take all the share. But when the things were in between, what Netscape Navigator thought is that what we can do is we can go to a standardization organization which standardizes things when it comes to computer stuff. And they went to ECMA, which is European Computer Manufacturing Association, and they asked to standardize JavaScript. And so they came up with something called ECMAScript. Okay, so ECMA is the organization that standardizes JavaScript. What it means by standardization is that they write what this language is, what is the syntax, what it will do. So it does not write the implementation. Okay, it just writes the requirements. So think of it as a client requirement. When you get a client requirement and you write software, right? So that requirement is very different from the software code itself. So think of ECMAScript as the requirement. Like this is what it needs to do, and all that stuff. And there was a proper standardization process in that. So now what happened is why they decided to do this is they thought if we standardize JavaScript as the main thing, there will be more web browsers that can say that, oh, this standardization is available and we can do our own implementation, and there will be more healthy competition which can where more browsers will come and implement JavaScript. So JavaScript will become main thing and JavaScript might end up dying. So even Microsoft thought that, okay, if this is an open standard, even we can go ahead and follow the same standard. They did it half-heartedly. So they followed ECMA for a while, for a year or two and whatever, and eventually they were realizing that they have already like eaten up Netscape, so they don't need ECMA or whatever, right? So this trick worked for Netscape for a while, and then it died down. So this common standard that was needed, there was a reason for that, because when there was two major things, Internet Explorer and Netscape Navigator, or JavaScript versus JScript, what happened is most of the website either worked in Netscape or worked in Internet Explorer. So it was a common thing to see on a website which shows best viewed in Internet Explorer or best viewed in Netscape Navigator. Or sometimes the websites will have two versions. When you go to their homepage, they'll ask you to select Netscape Navigator or Internet Explorer, and you go to that version. So it was obviously annoying, right? Imagine if there was another third browser that come up with their own language. I don't know, any script, let's say, right? And then there is this third browser running any script, JScript, and then JavaScript, right? Then there is three versions. So standardization was needed for sure. And ECMA did its work, and Netscape tried really hard to do this, but Internet Explorer didn't think that they need ECMA to come in this whole picture, because Internet Explorer was eventually becoming a major thing anyways, right? So what happened is Netscape is overtaken by AOL, which is America Online. Okay, it was a big deal back then. America Online was one of the biggest internet companies back then. And somebody might think that why a company will buy Netscape, which is obviously has this major product, Netscape Navigator, and there were other products, but Netscape Navigator was the cash cow for Netscape. And why would AOL buy it? Because there was a lot of patents also with respect to the same technology, and AOL was interested in not only the patents but also in the team. And since they had all the money in the world, they thought they can come up with something cool with Netscape or Netscape Navigator itself or whatever, right? So they decided to go ahead with overtaking Netscape. I think it was 4 billion or something like that. And what Netscape decided to do is that they realized that they cannot compete with Internet Explorer. And what they'll do, they'll open source the code of Netscape. And why would they do that? Not because they are such a hardcore believer of open source and they believe in code or whatever. This was a nice strategy. They thought, if we open source Netscape, what will happen is a lot of hackers and programmers around the world will adopt to Netscape, and we will get literally free contributions to the source code of Netscape if this strategy works, right? And if you have the whole world working for you as programmers, obviously Internet Explorer cannot beat that. And if you have ever if you are somebody who remember the pre-Chrome era, you'll remember that Mozilla was such a big deal, and everybody used to use Internet Explorer to literally just download Mozilla and then use Mozilla only. Okay, so what Netscape did is they always used to like the name Mosiac, because Mosaic was their own baby, Mark Anderson's own baby. So they wanted to come with a name for the new browser or new organization. So what they did is they combined Mosiac plus Godzilla, and they created Mozilla. And the open source thing worked, and AOL agreed that they will keep it open source because they liked their strategy and it made sense for them, although the patents were only theirs to have. Although later on those patents, AOL sold those patents to I think Facebook, and Facebook sold some of those patents to Microsoft, which is an interesting turn of events. And if you want to know this whole process that went into creating this Mozilla.org, there is a YouTube documentary that you should must watch, which is Project Code Rush. It is very interesting thing. You will see the real developers having real stress creating Mozilla thing. You will realize how the 90s were when it comes to hacker culture and startups that were made around no bullshit corporate stuff, only around coders and their lifestyles and their values and things like that. So it's a must watch. You can see the link to this documentary in the description. So yeah, if you haven't watched Project Code Rush documentary, you must watch it. This is literally a hidden gem that I found out when I was researching for this particular episode, and it shows you a lot of things, and yeah, it's just beautiful thing to watch as a programmer. So Mozilla was founded, and that's how this thing started. There is an interesting thing to remember, that when in this era when Microsoft was such an evil corp in the eyes of the hacker culture, right? A lot of people joined Mozilla just to beat Internet Explorer. So that was also a thing, right? So right now there is the thing, same thing about Amazon and Facebook. There is this hacker culture that do not like the practices by Facebook and Amazon, right? What it do to their competition, or what how Facebook uses data, and all those things. So same thing was with Microsoft earlier. The free open source software organizations really didn't like Internet Explorer or Microsoft for that matter. So that was the thing, and these are the three things that I'll show you, right? One is that I'll show you how these Internet Explorer or Mosaic or Netscape Navigator feel like. Okay, we will use them in an old operating system. So there is this website called oldweb.today, and what it does is it has this emulator on the web that runs old Mac OS operating systems, and you can use the old Mosaic or Netscape Navigator or Internet Explorer versions and experiment with those and see how it feels like to use those, like how people have used them in the 90s or early 2000s, right? Then I will show you a terminal based browser, Lynx. Lynx is one of the browsers that are being supported code wise till now. Okay, so it's a living code base that is I think more than 20 years has been passed, and Lynx is still being supported by the community. So it's a rare web browser that runs on terminal that is still alive from 90s till now, right? Maybe more than 30 years old. And then there is this website that I will not go to, but you can go to if you want to, and you can see the visual history of Mozilla, like how over the time Mozilla Mozilla's website also, the mozilla.org, and the browser itself also, like how it changed UI wise and what features were introduced, right? So now what happened is the web was also changing, right? So if you have watched Social Network movie, you will see that when Mark Zuckerberg and there is this female lawyer of hers, or somebody in the team of the lawyer, they're having this case discussion around a round table and all, and then there is this girl who Mark Zuckerberg I think sent friend request to, or the other way around, and then that person keeps on reloading their web browser because they're not sure if the friend request is like being accepted or not accepted or whatever, because there was no real-time notifications or updates to the website or content unless you reload the page and ask the server for the same URL again, right? And then there was this new thing which is Ajax, and what Ajax did is it asynchronously behind the scenes goes and fetches data from server and then gives you in the same page without reloading the web page. And then once you have that, you can use JavaScript to say that, okay, I have new data, let me update this UI or let me show you things, right? So if you have used the earlier version of Facebook, you might have remembered that you used to go on walls of people and you don't do anything, and then it keeps on changing your news feed and things like that, right? And that was such a big deal in Facebook because you don't leave the web pages, right? These days obviously you do not refresh much, you do not go to any other page, you are just on the YouTube, and YouTube shows you a lot of stuff, and you click on a video and then it shows you different recommendations and things like that, or maybe a news website or whatever, right? Instagram or whatever, you go to a web page, you do not go to different pages or reload pages so much, not just so much. I don't think you reload page unless there is literally something crashing, or you feel like, okay, something broke in your web browser, or the page is taking too long, or whatever, right? Reloading was such a major thing back then. So Ajax came with this idea, and there was like no more manual reloads, right? You basically use Ajax to update your web page without reloading it, and that was a big deal, and that changed, that became the future of web as of now, right? Even though if we do not use Ajax itself, we use something very similar, right? So we use the Ajax like stuff, which is fetch APIs and all those things behind the scenes now. Now what happened in 2008, Google jumped in, right? Internet Explorer was a major thing when it comes to web browser, and Mozilla Firefox was a major thing. Netscape Navigator already died. There is no Netscape Navigator anymore. And Chrome's come in 2008, and it literally changes everything. Why? Because Chrome creates this game changer browser because of the JavaScript engine that it has. Okay, and the JavaScript engine is basically nothing but JavaScript interpreter, and they named it after a automobile engine, which is V8. And V8 was super fast and open source and way better written. So when they introduced V8 and Chrome and everything, they had the best plan with respect to web and performance. And then they introduced the WebKit layout engine for the UI part of the web browser and all that. And Ryan Dell created Node, which is a big deal if you come from JavaScript ecosystem. And Node literally runs on V8. Okay, so V8 is not very tightly coupled with UI stuff. Since you know that Node can run or does run behind servers without any UI, and you can use JavaScript for backend stuff, Node enabled that, but V8 enabled Node to do that, right? So they write this JavaScript engine in an isolation with respect to web browsing stuff. So they knew JavaScript is a generic language, the interpreter should also be generic, and they made a lot of changes. For example, they made just-in-time compilation, which is basically you do not just interpret JavaScript, first you compile it to a bytecode and then give it to V8, right? And that made JavaScript really fast. And obviously there had been way more optimizations in V8, and over the time when V8 versions came, it just improved. But another major thing that Chrome or Google did was that it went back to ECMAScript. So now Mozilla and Chrome, and eventually obviously Internet Explorer will also end up going to ECMAScript and accepting ECMAScript as a thing. And after this thing happened, ECMA became again a standardizing thing, and the whole process started again, and that's why ECMAScript. So eventually what happened is JavaScript ended up updating quite fast, and now every year a new version of ECMAScript comes. So earlier they used to go with the version ECMAScript 6, 7, something like that, but now they do not do this ECMAScript 6, 7, 8, 9, 10, 11. Now they directly go for the year, because every year there is a new version of ECMAScript. Browsers implement that version. So now we do not say ES 20 or ES 19. We say ES 2018, ES 2019, 2020, and this and that, right? So that's the thing. So a lot of people who start with JavaScript, they kind of get confused with what is JavaScript and what is ECMAScript. So ECMAScript is nothing but a standardization so that everybody can follow the same JavaScript version, because everybody has different version of interpreters that they have created to run JavaScript, right? For example, Microsoft's Edge runs on Chakra, whereas Chrome runs on V8, and I think Mozilla use SpiderMonkey. So they have their own interpreters. They own the code, or the code is open source, but intellectual property of that organization. And that's the whole idea basically. Implementation is your problem, but you have to follow this particular standard. And when it comes to ECMAScript standard also, there are a lot of people involved in this, people who come from these organizations such as Mozilla, Google, Facebook, and all those places, and they are considered the experts when it comes to JavaScript or browser implementation and all that stuff. And they have a voting system where they decide like what works, what doesn't work, what should be the future of JavaScript engines and JavaScript language in itself. So that's the idea. So when Chrome came, it literally changed the game. It helped JavaScript as a programming language, and it kind of put the last nail to the coffin of Internet Explorer itself, right? So after Chrome came in 2008, things changed for the web, and there were new frameworks on the web. People realized that vanilla JavaScript might not be the future, and they should make web development easy by creating components, by creating frameworks, right? And two major frameworks of that time was AngularJS and Backbone.js, right? And Angular was earlier created as a commercial product by Misko Havery at Brat Tech LLC, but that didn't work for him, and he open sourced. And after open sourcing, Angular became a big deal. And Angular was based on component based, whereas Backbone was based on model view controller MVC stuff. And Angular was declarative while Backbone was imperative, right? So declarative is when you tell what to do, and imperative is when you tell how to do stuff, right? For example, when you write C or JavaScript or Python, that's imperative, because you say that do this and then do this and then do this and get me three things and go to this index and then loop and change the variable and this and that, right? You're saying how to do anything. But in declarative, you just say what to do. For example, you do that in SQL. You just say that get me first 5 rows of this table, right? Or get me something where this is this and group by this and order by this, right? You do not tell what is the strategy to do that, right? So Angular was declarative, so you do not have to worry about how that will be done behind the scenes. You just say what you want. So, and you created components, and that was the idea. Eventually Angular changed a lot, and the version of Angular that we see today is way different than what Angular was back then. And especially when React came, Angular also realized that there is this heavy competition that is created by Facebook, and Angular really took a lot of changes in its way of doing things, and I would say it became way better than what it used to be. So yeah, early 2010s was basically the frameworks that was the major frameworks were Angular and Backbone. And this is where you can see the additions of ECMAScript itself, right? So June 1997 there was the first edition, and in the third edition regular expressions were created and things like that, right? And you can see that ECMA from 2015 they started taking this ECMAScript 2015, 2016, 2017, right? They started using that name instead. This became confusing because people used to have like, okay, ES6 is ES 2015, like how is that related? So they were going with version 1, 2, 3, 4, 5, 5.16, and then they realized that doesn't make sense to call ES6, ES7, ES8. Let's just go with years, because anyways JavaScript is being updated every year now. So now we do not go for ES12 or ES11. It is more like ES 2020 and ES 2021. ES6 was a big deal because there was a lot of new things that happened in ES6. This is a screenshot from Wikipedia, so if you want to see those versions and what happened in those versions, you can just go on Wikipedia and find this. I'll also add the link to this in description. Let's go in the next one. So how is this whole process of adding new features on in JavaScript programming language works? So there is this technical committee 39, that is the team that works with ECMA organization, and these are the people who work on this. So if you want to read the whole process, and even if you want to see the features that are right now being proposed, and maybe next year or next to next year they might be part of JavaScript, you can read my blog. I'll add the description to this particular link. I'll add this link to my description also, so that you can just click and go and read the whole process, and it's very interesting. I wrote this blog a few years ago, so you might find some information being repeated in the blog. Now what happened is, JavaScript became a framework thing. People realized that you do not need to do everything by hand, and there are some patterns that you can use. There was a time where Backbone.js, jQuery, Ajax, and Angular was the whole game. But when React.js came in, React changed literally a lot of things. First, it introduced JSX, which is this new syntax of writing components, which looks like HTML, but it is nothing but an extended version of JavaScript, right? So JSX is actually not HTML, it just looks like HTML, so that when you write your own components, it feels like HTML, right? But you need a version of you basically needs JavaScript to interpret that, instead of like plain HTML doesn't need JavaScript, right? But JSX needs JavaScript engine and the React library, so that JSX can be interpreted for its proper meaning. And if you see the web before React, if you see the vanilla web especially, there was this separation of concern, SOC, right? And what we used to do when we used to create website, we used to say that you write HTML pages and then you link CSS and you keep CSS separate in a different file, and then you write JavaScript and keep JavaScript separate in a different file. And that used to be a good modular structure, that okay, keep JavaScript in one file or multiple files, but separate from HTML and CSS, same for HTML, same for CSS. And that was the perspective to look at modularity. But what React said that no, don't do that. Instead of HTML, CSS, JavaScript, looking at very technical perspective, look at usability, right? Create components. Create a component like a button or calendar or anything that makes sense for your UI, and make this modular thing in terms of components instead of HTML, CSS, JavaScript. So every component can have HTML, CSS, and JavaScript, but the modularity comes at a component level instead of at technology level, right? And then what React did is that why the name is React.js, because what it does is that you keep a state of the web, your UI, and if the state changes, right? If the state of the UI changes, maybe you got new data, or maybe user did something, you say that, oh, user clicked here, or oh, I got new data, let me change the state because this happened. And once you change the state, there will be new view, right? It's not necessary, but that's what it is used for mostly. So if new data came to you, or any data came to you that you feel like, okay, I have new information to be shown, or user clicked this button, or user scroll down, or whatever, right? So you react on the basis of those two things majorly. And React.js reacts actually, and what we call is re-render. Okay, you display new stuff. So you do not say that, okay, stuff, show this. You just say that this things depend on this state, right? So view becomes a function of state. That's the whole idea in React.js. And once you write React, you see that, and it's beautiful. These three ideas of looking at separation of concerns at a component level, introduction of JSX, and making view as a function of state, React literally changed everything, and it's just three beautiful ideas, to be honest. And there is this thing about JavaScript that JavaScript is a language that went through a hell of time in its lifetime till now. And in 2007, Jeff Atwood quoted this thing, said this thing, which became a quote or even a law, which we call Atwood's law, that any application that can be written in JavaScript will eventually be written in JavaScript, right? Which is very similar to Murphy's law, which says that anything that can go wrong will go wrong. And in 2007, this might look like an exaggeration of use of JavaScript, but if you see today, this is so true. You can literally use JavaScript for machine learning. You can use it for video game development. You can use it for desktop applications. You can use it for game development. You can use it for mobile apps such as React.js and things like that, React Native, and obviously web development, right? So anything that you can think of, most probably JavaScript is there. Anything that you can think of as a library, there must be a JavaScript library already for that, right? So since this is so true, it became a law. Jeff Atwood and Joel Spolsky created Stack Overflow in 2008. So Jeff Atwood is not some random guy for that matter, and if you are a developer, obviously you know about Stack Overflow, right? So this is a famous thing when it comes to JavaScript, which is Atwood's law. So I included that, and as you can see that JavaScript went through all these phases and new frameworks and different JavaScript engines and all those things. And Node literally played a big role of making JavaScript available everywhere. For example, backend, right? And nobody thought in early 2000s that JavaScript will be used for backend stuff. And when it comes to even frameworks, there is this routing or rendering kind of thing, right? For example, when it comes to React, we say that, okay, let's do one thing. Let's only ask for data from server, and we keep the whole UI part on the front end, right? So you download the front end like a mobile app. So once you have the mobile app, you do not keep on downloading the mobile app, right? You just log in and you get data, or you don't log in but you get data and all that stuff, right? For example, if you download a video game on your mobile, you are playing the game and the game lives in your mobile, but you know that there is data going and coming from the mobile app or the game, right? So that was the idea with React or other frameworks. That was not something that React invented, but the idea is in single page applications that you do not say that, okay, for every single page send me HTML, send me the whole thing again and again and again. You just say that, okay, send me the view, and then I will know that this is how the boxes look like. But when it comes to content that is dynamic, I'll ask you for data. So I'll do API calls to the server, and I'll ask server for data. So I know how to display stuff. All I need is information to be displayed, right? And then sometimes that's not the best strategy. So Next.js came in after React, and it said, okay, let's not do this. Maybe we need sometimes to fetch the whole thing from server, and we need HTML also from server again and again when we ask for it, which is the old way of doing things, right? That's how the PHP website used to work. That's how most of the things used to work before single page applications. You literally ask for the whole web page, and whole HTML, CSS, JavaScript, and the information come in bundle with bundled together basically, right? Maybe different separate files, maybe a single file or whatever, depends. So next said, maybe we should take an hybrid approach. Maybe we should give option to developer depending on the use case. And then there is frameworks such as Fresh, which is on the extreme left, which never sends information separately, which says that, okay, you always get HTML, CSS, JavaScript and information from server whenever you ask for something. Okay, you do not just keep the view and ask for information. You go old school. You do server side rendering. Okay, you do not do client side rendering. So extreme right is client side rendering, which is the view is rendered at client side, the HTML, CSS, JS is interpreted and the views are created on the go depending on the information that you have received, and you react on that, or you get proper HTML, CSS, JavaScript and information embedded in it from the server, and all the browser does is display it, right? So if you have a very light server, okay, and you are somebody who's maybe a student and you cannot afford lot of computation, so maybe you can go with a React project, right? And where you say that, okay, what I'll do is I'll just send you the view and you can ask me information and again, and that will really reduce the server load. So it totally depends on use case, and it totally depends on what you want to do. No approach is perfect, and that's kind of the current state when it comes to JavaScript and things that we do with JavaScript. And that's pretty much it. So in the next session, what we are going to do is we are going to talk about variables and data types. But before I go, I want to show you two things. One is the Lynx browser itself, like how a terminal browser looks like. And the second thing that I want to show is the website, which is old web website. So let me show you the links, this oldweb.today and the Lynx browser, right? So let me show you the Lynx browser first. So I'll go to my terminal. So I'm in my terminal now, and here I have already downloaded Lynx, Lynx, and depends on which browser you are, you can just Google how to install Lynx on Windows, whatever, or Linux or Mac OS or whatever, right? It should be super easy to do that. And how you use it, you say Lynx Lynx, and you just mention the website. For example, I am saying kherashanu.com, right? And I go to this, it says unsupported URL scheme. So I made a mistake. I'll do HTTPS. I did HTTPS instead. So I'll go now, and you can see that the website is literally visible. I can use arrow keys to go here and there, right? And I can read the whole website content here. And yeah, that's basically pretty much it, right? So I'll quit this, and to quit, I think you press Ctrl C, or there might be some other options to quit it properly. So I want you to experiment with Lynx. You will face two things. One is Lynx will annoy you when there is a lot of cookies for that particular website. Second thing is, obviously it doesn't support JavaScript, so when you see the website, some websites will not work at all because they depend heavily on JavaScript, and some functionality obviously won't work for others, right? So that's the idea. And why I want you to experiment with Lynx is that I think a lot of people do not imagine opening websites in a terminal. So that's a good exercise to do, to realize that there is a lot of things that you just take it as natural, which is not natural, right? Which is actually over the time became natural for a new generation. But this is how a whole generation of developers and internet users used the earlier version of web on the terminal. The second thing that I want to do is the link that I mentioned in my slide, right, which is oldweb.today. So let me go to Chrome and go to oldweb.today, and in the browsers we'll select Mosiac 2, which is a very old browser. Way before Netscape Navigator was a thing, Mosiac was created. I don't know when was Mosiac 2 created, but yeah, Mosiac is one of the first GUI browsers. And let's go to actually newyorktimes.com, newyorktimes.com, and let's read the news from newyorktimes.com a day after 9/11 happened, right? So we go to 9 12. Reload the whole thing and just wait for the whole thing to work. So this is a website that uses macOS emulator written in JavaScript, which is running Mosaic 2 in the OS, and you can obviously use the whole OS by clicking here and there in the OS. And now we are opening New York Times in this, and as you can see, let me make this, not sure if I can make this window bigger, so I'll just scroll little bit, and as you can see in the news, they're talking about Taliban and all that stuff. So Taliban to face swift deadline, blah blah blah. Thousands of refugees fled Afghanistan today, fearing possible strikes by the United States agent against Afghanistan in an attempt to flush out Osama bin Laden and all that stuff, right? So behind the scene is literally reading archive.org's archives. It's not real time, obviously, because New York Times does not, you cannot just go on a particular date on New York Times itself. So what they have done in this particular website is that it is giving you this whole interface to experience these old browsers that we talked about, and how surfing them felt like, and how far long we have like literally came in the journey of web and web surfing. And you become if you are somebody who is old and who has seen these browsers, you become nostalgic. And if you are somebody who is young, you become happy that you don't have to go through this experience, and what you have is like really awesome compared to what they used to have computation wise, and what things our web can do now. And yeah, that's pretty much it for today. In the next session, we'll talk about data types and variables. It is not going to be a boring session like how people have sessions about data types and variables. I'll be talking about a lot of things and a lot of details about data types and variables that is not covered in a average tutorial. And yeah, that's pretty much it. Thank you for watching.